Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for chapter 2.2.6. We've been learning about how to multiply fractions and mixed numbers together. And so here we have 4 examples of mixed numbers that need to be multiplied together. Now, there are a couple of different approaches you could take, but honestly, I think the easiest approach to take with these problems is to change each one of these mixed numbers into a fraction. And keep in mind, the idea here is if you've got 1 1/3, if I were to draw a picture of what 1 1/3 would look like, it would look something like this. I want to figure out how many total thirds there are for 1 1/3. So if I break all of my wholes into thirds, then I count 1, 2, 3, 4 of them, and that fraction becomes 4/3 instead of 1 1/3. And the process that you would use involves you taking and multiplying the denominator of your fraction times the whole number, that is equal to 3, and then once you've got that answer, add in the numerator, and that becomes your new numerator. So 3 plus 1 is 4, so that's 4/3. 1 1/2, you'd have 2 times 1 is 2, plus 1 is 3 halves. And if I draw the picture that represents 1 1/2, if I cut this in half, you got 1, 2, 3 halves there, so 3 halves. So now you can multiply them together. And let me show you a couple of different strategies. First, you can start by multiplying straight across numerator times numerator. Denominator times denominator gives you a 6, and then simplify to give you an answer of 2. Or what some students like to do is they like to think of the simplification first. So let me actually clear, I'll do it down here. So if we take 4/3 times 3/2, if I were to use commutative property and rearrange the 4 and the 3, then this should become 3/3 times 4/2, in which case that would form a giant 1 that would cancel out. So that leaves you with a slightly easier fraction to solve. 4/2 is the same as 2, right? 4 divided by 2 is 2. So if you want to, you can multiply straight across, then simplify, or you can begin the simplification process while it's still a multiplication problem and just cancel out common factors as you go. In fact, I'll take it one step further and say 4/3 times 3/2 can be expanded out into prime factors. 4 is the same as 2 times 2. So that becomes 2 times 2 times 3, which is equal to 12, right? And in the denominator, I'm going to actually put the 2 first and then the 3. And you'll notice a giant 1 here, a giant 1 here. Excuse me, you're left with a 2 in the numerator. And when everything's been canceled in the denominator, you still kind of have a factor of 1. So that's one thing to sort of remember. But still, you know, there are many different ways that you can simplify a fraction. You can expand it out and cancel out the common factors. You can multiply them together and divide by the greatest common factor. You just decide which way works best for you. But the bottom line is you got to get the answer in simplest form. For problem B, 3 1/3 times 2 1/2. Well, 3 times 3 is 9, plus 1 is 10, so that becomes 10/3. And 2 1/2, 2 times 2 is 4, plus 1 is 5. So if you want to do some canceling here, you can. I could cancel that and that, divide a 2 out on either one of those and make that a 5 and make that a 1. So you end up with 25/3. And now 25 divided by 3 is 8 with a remainder of 1. So that becomes 8 1/3. Okay, so I'm not going to do C or D. If anyone has any questions they want to ask about those problems, I'd be happy to work them out for you. But I'm going to move on for this video. Below is a fast mental math technique to find 5/6 of 24. Remember that 5/6 of 24 is the same as taking 5 times 1/6 of 24. So I like to create one of these boxes here. I used to do this with 5th graders all the time. This was like a big deal in 5th grade, was being able to find the percent of a number or a fraction of a number. So if we start up here and say this is 24, and I'm going to break this rectangle into 6 equal parts, so each one of them represents 1/6 of the total. So remembering, when you find a unit fraction of a number, 1/6 of 24 is the same as 24 divided by 6, and that gives you an answer of 4. So that means that each one of these sections has to be equal to 4. And that's the part right here. What is 1/6 of 24? It's 4. So now if you want to find 5/6, then we're going to take all of these. So you got 1, 2, 3, 4, 5. 5 times 4 gives you 20 for an answer. So therefore, 5/6 of 24 is equal to 20. Now let's solve this problem the traditional way. Let's change 24 to 24 over 1, and this would be 5/6. You can do cross canceling, or you could have multiplied straight across and gotten 120 divided by 6. Either way, your answer is going to be 20 for the answer. So a few different strategies that you can look at here. I'm a big fan of this visual representation of what it means to take either a percent of a number or a fraction of a number. Or you could just use the traditional means of converting these numbers to equivalent fractions, multiplying, simplifying, declaring your answer. All right, so let's go ahead and use that technique. If we want to find out what 3/4 of 24 is, it would be good to find out what 1/4 of 24 is, then multiply it times 3. So 1/4 of 24 is 6, and 6 times 3 gives you an answer of 18. 3/8 of 32 will be 1/8 of 32 times 3. So 1/8 of 32 is 4, and 4 times 3 is 12. And then 4/7 of 35 is 1/7 of 35 times 4, and we know that 1/7 of 35 is 35 divided by 7, so it'd be 5 times 4, which gives you an answer of 20. All right, so let's apply this to a word problem. While going on a field trip, a busload of 54 students will have to be split up into 3 groups. 2/3 will go to lunch first, and 1/3 will go to the exhibits. So how many students will go to lunch first? Well, we've got to figure out what 2/3 of 54 is. So let's start by figuring out what 1/3 of 54 is. 54 divided by 3 is 18. So double that, and that means 36 students will be going to lunch first, which means that the remainder will be going up to an exhibit. And if you add 36 and 18 together, you should get 54 for your answer, and you do, so you know that you've done all the math correctly. And the last problem, graphing. This is going to be a really big issue in 8th grade and in high school, where we're going to be solving lots of problems by doing graphing. So we need to understand the basics of how graphing works. Each one of these is called an ordered pair. And each ordered pair has numbers, obviously, it's a pair, and they're put into order where this first number references the number on the number line for the x-axis. See, the x-axis is a number line, and the y-axis is also a number line, but this one is vertical. So the second number will always reference the number on the y-axis, or the y number line. So what we do is we always start at the position called the origin. The origin is right here at 0, 0. And that first number in the ordered pair for A was -2.2. So we're going to go to -1, -2, and -2.2 is going to be somewhere around here. Then for the y value, it was 4.64. So I'm going to go to the origin again and go 1, 2, 3, 4, and a little bit past the halfway point is right around here. So when we converge these 2 points, move this guy vertically, move the other one horizontally, you get the approximate location of where point A should be. And it's always a good idea to label it -2.2, 4.64, but I just labeled it as point A because there's point A right there. So you could do it either way. You could either use the letter that corresponds to the ordered pair, or you could actually write in the ordered pair. But it's really important that you plot the point and label which one we're looking at, okay? For B, you got to go to 8.2 and 7.59. So 8.2 is right around here. 1, 2, 3, 4, 5, 6, 7 point, what was it, 7.89? 59. So a little bit past the halfway point here. And where do those two converge? Right around there. For point C, negative 3.47, so negative 1, negative 2, negative 3.47 is going to be somewhere around here. And then negative 9.3 3/10, 1 negative 9 and 3/10 is going to be somewhere around there. So these guys would converge right around here for point C. And then point D is 0.62 on the X line, so that's going to be somewhere around here. And negative 5.1 on the Y line, negative 5.1 is going to be somewhere around there. So this is going to be where that point is. So when you are graphing, it's very, very important that you make sure that all of these tick marks for your scaling are evenly spaced. And that's why it's always a good idea to use graph paper whenever you are graphing so that you get those perfectly spaced. Because oftentimes students do it on a blank piece of paper or just regular lined paper, and it ends up looking horrible. Absolutely horrible. These are not properly spaced. They're not properly labeled. They're not even straight lines. So I highly recommend anytime we're doing graphing, use graph paper. Okay? Please be neat and orderly and follow the grid. Okay? Don't just decide you're going to put your own counting sequence in. Those lines are there for a reason. Use the lines. They're properly spaced. And decide on what your scaling is going to be, whether you choose to count by 1s, 2s, or 3s, or 5s, or 10s. Doesn't matter, but it just needs to be consistent. Okay? So that does it for the homework. Let's move on to our next activity, most likely our lesson for 2.2.7. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk